Today we're going to learn how to make things move. Now, this is a part of a playlist. I'll have the link in the comments pinned, and we're teaching you, ideally, how to think like a programmer. And this is another step. Now, this video today comes after the first tutorial, which was an introduction to Typescript. But after a few more videos come in, the order could be changing quite dramatically. Now, order doesn't matter too much, as going forward, you're going to have the foundation principles. I will try to order them in a way that makes sense logically in the playlist, kind of like from easiest kind of introductory stuff into later stuff. And today we are taking it slower. I'm going to try to stop and explain a lot more, do a little bit better. Yeah, but we're going to be making things move. The plan for the whole video, just so you have an idea of what's coming, is we're going to start by using onUpdate. Then we're going to use a overtime manager utility that I built. And then we're going to clarify some things about using up for your locations. So whether you have world up or object or up. And we're also going to be talking a little bit about parameters to make things a little bit more customized. And the idea is that motion is kind of a core building concept to most games. So that's where we're going to start. We're going to try and keep things a lot shorter, smaller, bite-sized pieces going forward. So ideally, there should be a lot of smaller chunks, and you can look for the topics that you're interested in. But yes, just as before, feel free to join us on Discord to ask questions and leave comments and questions as well. All right, so without further ado, let's dive right on into the Horizon desktop editor. And I'm going to start by creating a new world for this, just so we can see an empty world progressing. Shouldn't take too long. And there is an asset that we're going to be using. I've already uploaded it to the public assets in Horizon. So you'll be able to find that by going to the public assets and typing in Vidyuu. I'll show you that a little bit later. It's the overtime manager asset. And what that does is it takes a lot of the hard stuff away and makes it a little bit easier to think about motion. All right. In fact, there it is right there. Okay, I prefer to look at the console though. So welcome into the desktop editor. We're still getting used to this. We're still learning. So remember, right click to look around. We can use our WASD keys to fly around. And then Q and E goes up and down. And you can also select something and press F to focus it, and then scroll wheel to zoom out from there. Lots of things. I'll try to remember to say what I'm doing and clicking on so it's easier. But what I want to do first is bring out a new shape. Let's go ahead and use something kind of neat, like this truncated pyramid seems kind of cool. And what we're going to do is flip it over. And I like to start with the art side of things. It's just something I really enjoy. So I'm selecting the snapping rotation right here, setting it to 90 degrees, and then selecting rotation, and then rotating it upside down, so 180 degrees, to make it look like a platform that you could imagine standing on. I'm then going to move it to 0, 0, 0, so that we can see where it's at relative to a player and what that looks like. And that looks pretty good. Let's now go ahead and move that forward on, let's see, the x-axis by 2. Oops, let's try z-axis by 2 meters. And what I want to do with this first is get it moving upwards. And so we want it to slide up by 2 meters. To do that, we're going to need a script. So we're going to go to the scripts button up here. Go ahead and click create new script, this plus icon. And then the name for this script is going to be called moving platform. And then I like to use postfixes to describe what the thing is. And this attaches to an entity, which is entity. An entity just means any object that can have a script attached to it. So there we are. And now that we've got this script created, there it is. We can now select our entity, scrolling down, attach the script, and select moving platform. Okie doke. Now that we have that moving platform script attached, we can now edit it by going scripts dropdown, 3 dots, open an external editor. Now this is going to open up VS Code. Presuming you have already installed VS Code, this is going to work, no problem. If you have not yet installed VS Code, well, you might want to do that. I'm trying to make sure that I can see VS Code and switch between these two easily. So I'm going to move that down like that. Perfect. And then once you install VS Code, you will need to restart your computer for it to link into the desktop editor. All right, I'm going to go ahead and click yes, I trust the authors, and allow. If you don't click those buttons, it can cause some weird issues, so I do recommend pressing them. We're now going to delete the import line at the top. And this is my personal preference. I really prefer explicit importing. So this, when it's not like that, has HZ dots everywhere when you use the Horizon API. And I just don't like to see that in my code. So we're going to go ahead and delete HZ dot anywhere they are. There we go. And then to explicitly import, you hit Control period and then click Enter, which adds the import for Horizon Core component. There it is. And now that that's done, we have updated our default script. Now, remember, we want to move this upwards. So I think now is a good time to take a moment to explain the basics of this script. I think it's good to always go over, especially since we're just getting started. And so the first line here is everything we're importing. This next line is the part that we use in Horizon. This is what it'll make. By making a class, we can attach the script to an entity in Horizon like you saw me do. And what a class allows us to do by making it entity attachable is make more than one copy of it. So a class represents kind of something that you can create multiple of. And when we make it something that can attach to an entity, like we are able to do down here, you can imagine having more than one of these. So if I hit Control D, I can duplicate, selecting the Move tool, then selecting snapping 1 meter. I can slide that over 2 meters by 2 clicks there. And you can start to see these platforms taking shape. I am going to actually change this to be up by 1 meter. I think that looks good, and then maybe over by 2 more meters. Nice. And maybe we'll go over 1. So the point is, now there are 2 things running this script, and that's what a class allows us to do. We can now have 2 individual copies of this script running, and it's this section of the script, this class portion. Now, what you're going to read here on the line 1 is this is the name that we gave it, moving platform underscore entity. So this is our custom class name. It's extending component, which means it gets a bunch of Horizon API stuff, which you'll see us use in just a moment, like onUpdate comes from the Horizon API. That's a part of component, not really, but anyway, it's part of the Horizon API. So we have component. Then this type of is more or less making the properties panel work. And this second line that you're going to see is the props definition, which is your properties panel. That's over here, and we'll be using that actually a little bit later in the video, so stay tuned for more on the properties panel. Next up, we have start, and you might remember pre-start. I think now's a good time to mention pre-start. We will be using it, just not right away. So we'll click pre-start, and pre-start is a method. A method is like a function that exists inside of a class, and I don't like void. Void just means that it does not return anything. So if you leave it with no definition, like no type explanation there, it still means it returns void. Start also returns void. Anyway, I just like the way this is more readable, more clean. If you did want to return something, which obviously I can't because pre-start isn't something we made, you would type like return number. Now obviously this is going to be upset because pre-start does not return a number, it returns void. If you create a custom method called like my number getter, then you could return a number. And so that's how you can make a custom method like that. And a custom method is just like a function. So somewhere you could call my number getter to get a number, which we're not doing today. Okay, but anyway, so these are methods, and pre-start and start come from the Horizon API. They are triggered by Horizon just when you attach this to an entity. If you do not attach this script to an entity, these will never fire. And so if you hover over pre-start, you can see that this is guaranteed to run before the start of all other components. So all other entities will have pre-start run before start is run. So really nice. Okay. And now that we have this kind of like basic understanding, I guess there's one last line here, which is component.register. This is what makes it so you can attach the script in the drop-down panel, which was over here where we went and clicked attach script. Now that we have a pretty basic understanding of the code that is created for us when we initialize this script, we're now going to move the entity up by 2 meters on world start. So right here on start, we're going to, and I think I want to just take a quick pause here because I'm going a little too fast. I need to slow down, which is okay. We're getting there. And say, how do we think like a programmer? And we need to think about the end result, the goal that we're trying to get to. And if I didn't mention this already, the goal is to get a platform that moves up and down or from one position to another and then continues back and forth. that's the goal for today. I feel like if we teach that, you could easily make something that moves to a specific location just one time rather than back and forth and so on. So we're going to start with that sort of basic concept. And I'm going to show you how to make it really easy with a utility here at the end. But hopefully that helped explain. So our goal, the thing that we're trying to do, is get motion up and down. And we like to break it into the smallest piece possible. So when you're thinking like a programmer, we want to think from the back, like, okay, what's our final goal? Okay, how do we get there? Well, let's start with the smallest piece, which is just moving to that place instantly. So let's go ahead and try moving there instantaneously on start. And so right here, we'll say this dot entity dot position dot get. And it looks like I might need to close my camera down as I'm getting some lag there. Hopefully that'll speed us up. And now that we've got that set up, oopsie, sorry. I meant to go this dot entity dot position dot set. There we go. And we want to set our position to be 2 meters up from our current position. And so what you can see is position.set takes a vector value. So we can then say this dot entity dot position dot get. So now we've gotten the current position, and we need to add to that position with a value of 2 in the up direction, which you can do by typing period and then add. And you'll notice there's 2 different types of add. This add, if you hover over it, creates a new vector, so a new 3D vector. If you hover over this add, or arrow down to select it, you'll see that this one adds to the original vector. And this will modify, which isn't super relevant right now, so maybe we'll come back to that in a moment. But anyway, we're going to use add to modify the position.get value. And we need to add to that with that new vec3 with the parameters 0, 2, 0, where the 2 is the y value, so that's up on the y of 2, which is up in the world space. And now that we have that set up, we'll hit Control Save. Running over to Horizon, we're going to wait for that script to compile. It just takes a moment, clear. And then when that's finished compiling and we hit World Simulation on, you'll see that those 2 moved up instantaneously by 2 meters. Fantastic. All right. So now that we got that moving up by, I want to actually reverse that. Now that we've got that moving up by 2 meters, we want to make this happen slowly over time. And to do that, we're going to use onUpdate. Now, onUpdate might be something you've heard of before, maybe not. What it does is it returns, and it occurs once every frame. And so if the headset, if this is in VR, is running about 70 frames per second. If you are on mobile, it's about 60 frames per second. So we have this local method called onUpdate, and I've added the basic formatting, right? So parentheses where parameters go, curly braces where the code goes. Now in the parentheses, there is a parameter we're going to receive, which is the delta time. That's the amount of time between frame, and so that's a number parameter. And this is not built into, like start and pre-start are built in by default. OnUpdate is not. We need to connect it. This is the sort of thing you do need to just memorize, and it did take me quite a while to memorize how to make OnUpdate work. But the way that it works is you type connect local broadcast event, parentheses, so it's just like a regular event connection you might remember from the previous video. Now, though, there is no object to connect the event from because this is a broadcast event because it's broadcast globally across all entities. And so the event comes from world. So you have to type world and type enter to import it. That adds it to the import line. And then period gives you a drop-down list. And the one we want is onUpdate right there. And now that we have onUpdate, you might have noticed as we were typing there was onPrephysics update. We don't care about that one, but for those interested in that specifically, that does exist. We're going to use onUpdate though, and comma, and then just like before with a regular event connection, we do parentheses. Now this receives a payload, which is a JSON object, and a payload could have more than one item in it. In this case, it just has the one item, so we do colon, curly braces to create that JSON object, and then delta time is the parameter, or the property inside. I misspelled that. I'll fix it in a second. Delta time is the value we're receiving in the payload, which is a number value. And I'll add the T to make sure that's spelled correctly. And then we just need to draw our arrow to our curly braces, which is where we will connect this to our local onUpdate by typing onUpdate, which calls this .onUpdate, this referring to the entity's class, so whatever entity is running it, so it's calling the local onUpdate. And then parentheses to call it. We then need to pass in the delta time, which is payload.delta time. I like semicolons, so I add one here and one there. Shift-Alt-F to prettify it, Control-Save. And so now onUpdate is going to be called. And what I think we can do is demonstrate that that worked by just moving this into onUpdate. So I use Alt-Arrow to move the lines around. And what we're going to see when we save and compile this is that it does the exact same thing as before. And all that does is prove that our event did get connected and onUpdate is being called. So we're going to go read this one more time and then check it out. So line 7, in pre-start, we're connecting a local broadcast event from world.onUpdate. And if we hover over onUpdate, you can see that it's a local event. We're not talking about events too heavily today. And I do recommend avoiding using events in most of your Horizon coding unless it's a code block event, because code block events are basically the only way to get connected to like triggers and other things like player enter world. So there are some things that you need, but for the most part we want to avoid events. Then inside of, although there is networked events, I mean honestly those are topics for another day, so I'm just going to cut myself off there. Now here we have our payload, so we put those inside of golden parentheses. And the payload has delta time in it. And then we arrow to the right where we can call what we want to have happen when the onUpdate is received. And so we're saying let's call onUpdate passing in payload delta time. Now this is the best way to do this. You could technically, and I do not recommend this in any way, backspace this and create code that's running right here. So rather than creating a local method called onUpdate, you could just put all of your code right inside these curly braces. I just think it's harder to read, and I do not recommend it. I just very much do recommend calling a local method so it's very clear that this connects onUpdate to onUpdate. This is where onUpdate is happening. Much easier to read and make sense of your code. Okay, so then onUpdate is received with the parameter delta time, and we say this .entity position of that entity dot set to this entity dot position dot get, and add to that position that we just got with the new vector 3 of 2 meters up on the y value. And so that creates, so this whole section right here is creating the position that we want to move to, which is then, it's then set, right? All right, let's go ahead and see that in Horizon. We'll go ahead and clear these console logs. Go ahead and world simulation on, and they disappeared. Oh, now that's interesting. Okay, I don't know if you caught that, but it definitely worked. So if we hit play, boom, look at that. We've created motion over time. It's a little bit faster than we intend it to be, but it is kind of what we're going for, right? And that's why we were going to use onUpdate. Now, I think this is an interesting moment, like that we can take to change our code just slightly. Like imagine if we, instead of doing 2, we did 0.02, because remember this is happening 60 times per second roughly. And then we went and hit, wait for that to compile, it does take a moment. We've now created something that moves up slowly. Very nice. Cool, very cool. It's not perfect. Delta time is the amount of time that's happened between each frame, and if we use delta time, that's going to give us a much smoother motion over time. And so if instead of using 0.02, delta time, if we use delta time, it'll move up by 1 meter per second, which seems okay because delta time is in seconds, so it's like 1/60th of a second roughly. So we'll just type in delta time here, press Control Save, and now we're moving up at the pace of 1 meter per second. And we'll see that it should look a little bit smoother. There we go. Very nice. Let's see if we can make that better. There's something about this right one that looks a little choppy to me. It's kind of interesting. Not sure why. But let's make this better. And I kind of wanted to keep building upon this because I feel like there's something really quite neat about what we've done. And we want to move up, but how do we go back to the beginning position? Well, we need to know when we reach a certain value. So let's go to the top here. Below properties is where I like to put local variables. And so the first variable we're going to create is going to represent the start position. So we'll call this start position. It's going to be equal to a vector 3 dot 0, which creates a 0 vector. We can then initialize this on world start by saying start position equals this dot entity dot position dot get. And now that we've initialized that, we want to know how far up do we want to go. So let's create a new vector called up by, and that will be equal to 2. Sorry, not a vector, it's just a number, it's a number of 2. And what we can do is, I'm debating if I want to keep going down this path, because I know the way I taught it earlier was a little bit easier, but this is quite neat. I did like a practice run, so I'm like, do I keep going down this interesting path? I think we do need to adjust to get to our goal. I don't feel like this is heading towards our goal as well as I would like. We can still keep these number variables we've created, but what we want to do is start thinking about this differently, because our goal is to go up and then down. And so let's go and create a new Boolean variable called is going up. And this is going to be equal to true, as it starts by going up. Now on update, we can ask the question, if parentheses is going up, and curly braces, and then else, oops, Control-Z, and then else, and then curly braces. So we've created an if-else statement. So if is going up is true, then we're going to do something, else we're going to do something. And right now, this does go up, so that's cool. And technically, right, you could hit Control-C, Control-V, Alt-arrow down, and then set this to be negative delta time, and now it goes down. We're definitely not doing it that way, but it's interesting, to say the least. So with this kind of setup, what if we could track the amount of time that is elapsed? So right now it says if going up, we're going to move up. We know that this moves up, and else we think that this moves down. We haven't tested it, but we can prove that in a moment. And so if we track the amount of time that is elapsed, we could then know when to change which direction we're going to. So let's track time elapsed, and this will be in seconds, and that's going to equal 0 by default. And we want to know how long it's going to take to go to our destination. So this is saying we're going up by 2, but we also need to know the duration. So time, we'll call this travel time seconds. Travel time seconds equals 2 as well. And then what we can say right here at the beginning of our on update, and so I just, by the way, for reference, in case you didn't see that, I click enter, enter, up arrow, tab. So then what we're going to do is say time elapsed seconds plus equals delta time. So now we've added to the amount of time elapsed with delta time. We can then say if parentheses time elapsed seconds is greater than the travel time seconds. When that occurs, we want to start going down. And we kind of want to do this after the motion right below. So we want to put this at the bottom. And we want to put it at the bottom so that the motion happens and then we can change direction. And so right here, we'd say time elapsed gets reset back to 0. So time elapsed equals 0. and then is going up gets set to, so we use equals, not is going up. There we go. And the not operator is the exclamation point, and it means the opposite, right? So not true is false, not false is true. And so what that does is it takes the Boolean and it flips it from true to false and false to true. So with this setup, we now have reset it so it continues going in the opposite direction, and then after 2 seconds, it flips again. Let's go ahead and hit Control Save. We haven't started using the start position, and we haven't started using the up by. We will get there. For now, we're just getting this to proof of concept working. Clear. Go ahead and turn world simulation on, and there they go, up and down. And if we jumped into preview mode, you can now spacebar. Oh, I missed it. Can I jump on that? I need to start them lower. No, gotta start them lower. But yeah, very neat. Go ahead and turn that off. I'm gonna select both of these, and I think I'm gonna take the scale on the y-axis and change it to 0.5 so they're skinnier, and then drag them down so they're just at the level. Oh, right. Oh, that's almost perfect. Let's turn off snapping, and then looking down, slide that up just a hair. Perfect. Okay, so we've got that looking really nice, and we've got them going up and down, right? World simulation on. And you can already imagine this could make a whole game mechanic, just jumping, parkour type games, which is fun. Love those, love those. But there's quite a bit of work we still need to do to kind of finish this off and do this, what I'd say is like proper. I could stop here, but I really want to build some more foundational kind of like basics of the proper way to do this. And so we need a destination position. So we have our start position. Now let's create a destination position. So we're going to say destination position equals also vec3.0. I'm going to split these now. I like to split things into separate sections that make sense. Like time elapsed seconds can probably go up next to travel time, I think. I'm not sure actually. This kind of is related to is going up. I'm gonna put it there. So now that we've got this all kind of like set up, we need to initialize our destination position. And to do that, we're going to type Control-C, Control-V to duplicate the line. We're then going to change this from start position to destination position. And then we had our destination position by doing, you might remember, .add, and then parentheses, and then we said new vec3, parentheses, 0, comma, and now we can use that up by value we created. So this dot up by 0, Shift Alt F to prettify that. Looks good. And now we've got this destination position calculated. The problem is we're calling this.entity.position get over and over again, which is not great. It's called a bridge call, great moment to pull back the camera. And so Horizon TypeScript is great. We love TypeScript, huge fan. One of my favorite languages, probably my favorite language. Horizon is built on Unity, which uses C#. So when you make a bridge, the bridge is towards C#. So the position is saved in C#. So you're calling .get, which then has to communicate with C# and back. Anytime you make a bridge call, it can cause a slowdown. And so that hiccupiness we're thinking about, I didn't really address it because I'm thinking that's probably the bridge calls we're making. And so if we go and look at our script on update, we were calling this.entity.position.get every single frame. Like that's 60 times per second. That's a lot of bridge calls. And we don't really want to do that. And we don't even want to do it twice in start just to get into good habit. Like this really isn't a problem on start because it's just 2 times. But the better method is to type start position.add because we've already done the bridge call, right? Like we already have the start position. We don't need to call to get it again. So now we say this.startPosition.add that new vector. Now you might remember earlier I was showing you that there were 2 different adds. This is where add in place is dangerous and you want to make sure you're using the correct add. If you call add in place, it modifies the original vector. And so start position gets made, it changes start position, which we don't want to do. So that's why we're using add, which returns a brand new 3D vector. Okay, hopefully that makes sense. Continuing on, we now have a start position and a destination position. We have the amount of time that's elapsed, and we've got this is going up thing. What we want to do is move to the position between the start position and the destination position based on the amount of time elapsed compared to the total travel time. I'm going to show you a feature that is one of my favorites. It's called lerp. And to access lerp, you type vec3.lerp. And if you hit parentheses, you'll see that it takes two vectors, your start position, your end position, and the percentage of the way there. So that's vec A, vec B, and amount, where the percentage is how far along from position 1 to position 2 you want to be. And so this returns a vector that is somewhere between two other vectors. So what that means we can do is type start position, because we want to start at the start position. And then we want to go to the end or destination position. Oops, try that again. Destination position. And then we need to know how far along we are. And if you take time elapsed and divide it by the travel time, that will return a number between 0 and 1. And in fact, it will actually get slightly above 1. So we want to put this in parentheses and type math.minimum. And what minimum does is it takes two values and choose whichever is smallest. And so after doing the math, we can type comma 0, and that's going to make sure that it does, or excuse me, comma 1, and that's going to make sure it doesn't go above 1. So math.minimum keeps it below 1. And we actually need to do this one more time, because when we go down, it goes below 0. So we put parentheses around it one more time. We type math.max, and then we'll do comma 0, which will keep it above 0. So comma 0, or I put it in the wrong spot. The comma goes right before the blue parenthesis. You'll notice the colors correspond to each of these. So this blue parenthesis corresponds to this blue parenthesis. So this is kind of hard to see, but this is a clamp, and it clamps the value between 0 and 1. So I'm going to collapse this so it's easier to read the whole script. So this .entityPosition.set, vec3.lerp, which takes two positions and the percentage of the way through, so between start position and destination position, we're going to clamp it with a max and min between 1 and 0, and then the time elapsed divided by travel time will return a number that shows us how far we are into the elapsed amount of time. And for now, this is just going to work on the up if it's going up. We will adjust this to also do as going down in just a moment. So I'm going to hit Control Save. And in fact, I'm going to comment this out. And we're not going to run the code here, just for now. OK. So let's go ahead and clear. So what we expect to happen is it's going to go up for 2 seconds. Then it's going to teleport down after 2 seconds and then go up. So I'll go world simulation on, and there it goes. And 1, 2, teleport back down, and it goes again. There we go. Nice. So now we need it to bounce. And to create the bouncing motion, we're going to have to get this else working. And we can do that by just simply hitting Control-C, Control-V, and then Alt-arrow down. You can also hit Control-X to delete the old line of code, now that we have our new line of code. And you'll remember that lerp goes from a start position to an end position, and then in this case, our start position is the end position and destination position is the start position. Confusing? I know. But we basically just need to reverse this. So crisscross, crisscross, right? Sorry. So we got start position, destination position, start position, all good, and that is ready to go. Now this does function, but there's one more way we can write this code, which I think would be kind of fun to show you. Before we move on to a much easier way of doing this. World simulation is on, and now we should see that go up and down. Very nice. Looking good. I don't think it's nearly as stuttery. I'm wondering if it might be stuttery because it's hot in my room and I'm recording video, which kind of eats up processing power. But it looks good. It looks good. OK. So we got start position, we got destination position. We're doing fantastic. What I wanted to show was something kind of curious. I want to show something that I use all the time, and I would recommend using in this space. It's a little bit confusing though. So we're no longer going to need this if statement for is going up else. We just need one line of this code. So I'm going to move one up, and then we're going to delete this. And this line of code is pretty hard to read. Like start position, destination position, not too bad, but this little behemoth, not fun. So what we can do is we can say, dun, 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 constant percent elapsed will tell us the percentage elapsed, which will equal, and then we can take this right here, Control X and Control V. Now we have our percent elapsed, which can go right here, which is kind of fantastic because this row is now readable. But there's something else we can do based on whether or not we are going up. And let's see. It's just a little bit of math. And so if we go and say constant lerp percent equals, and so we could use percent elapsed, but then we'd still need the if else statement. But we can take lerp percent, and if this gets too heavy into the math, I'm going to try and read it back when we're done to really help solidify this kind of process, because I find it super useful, and it just makes writing code cleaner and shorter lines, which isn't everything. Readability is huge. You can take the is going up Boolean and then type question mark, and then if it is going up, we want to just use percent elapsed. Simple as that. If it's not going up, we want to take 1 and subtract from 1 with the percent elapsed. And what that'll do is it means it reverses the direction that percent elapsed counts, right? So it goes up to 1 when going up, but then when it's going down, or when we're going the opposite direction, it starts at 1 because it starts at 0 when it's going down. And then so it goes 1 minus 0 is 1. And then if you get all the way across, this has reached 1. And so 1 minus 1 is 0, and it goes all the way back to the start position, right? So now we just need this one line, and we can replace this with the lerp percent. There we go. Very nice. Control save. And that, I think, is where I want to end this. So I'm going to read this back one more time to help solidify what's going on here. So we're creating a constant value called lerp percent. It's equal to this stuff. But what this really is it's saying we have a Boolean. Based on what that Boolean value is, using this question mark, we're going to say if it is true, we just return the percent elapsed. So this becomes percent elapsed. Else, using this colon, then we want to change the value to be 1 minus percent elapsed. Okay. It's kind of like a really shorthand for an if-else. And like I said, I use this all the time because it reduces your code and it makes modifying this stuff a lot easier. So anyway, I hope that helps. I do think because of the way this is set up and it always starts at 0, we don't actually need to do math.max because it never goes down in this case. So we can remove math.max. And if I just run through this in my mind real quick, math.minimum is going to say when you reach above 100%, stay at 1. Don't go above 1. Perfect. Control save. We are all set. That is brilliant. It does mean that it never goes back to 0. So it's not perfect. And the next method I'm going to show you is a little bit better. There is some ways we could adjust the math in here to get it closer. For instance, if we're not going to. There definitely is some ways to change the logic in here, and that might be a good challenge for you to try, is like modifying this so that it starts at 0. So right here you can see that we're increasing delta time here. If we moved the incrementing of delta time That's it. Okay, it's way easier than I thought. If we move the incrementing of delta time down here to the bottom of the script, and I'm just going to combine these to make this more readable, then when we get here to the bottom and we find that time elapsed is greater than travel time seconds, we can then set it to 0. Now this actually means that it does not go above 1 because we are now checking that for that. Yeah, so now it doesn't go above 1 and you don't even need math.min anymore. But it also means that it doesn't reach 1, which is its own set of problems. So if you ever want to try tackling that problem, go for it. We're not going to in today's tutorial because the next method I'm going to teach you is a lot easier and it does handle that for you. But anyway, let's go make sure this code works. It's compiling right now. Should be done in just a moment. I think it is done. We'll go ahead and turn the world simulation on. We'll jump into preview mode and we can see that goes up and down. And I do feel like it could, I think it is smoother. It's hard to tell. But yeah, there we go. World simulation off. All right, now we're going to abandon this code and we're going to jump into a brand new script. And to do that, we're going to go to the asset library. In the public asset library, if you're watching this immediately, it'll be right here at the top. But assuming you're not watching this today, you'll go to the Creator tab and search Vidyuu for Vidyuu. And when you find Vidyuu, click on the profile, and you're going to see all the Vidyuu assets. And you're going to look for the clock, which is our overtime manager. We're going to pull that out. Go ahead and press OK. I'm going to switch back to console view. I'm going to also move this to 0, 0, 0. I'm going to then wonder why there are... I guess it is good. It is good? Oh, no. Well, anyway, I guess this wasn't at 0, 0, 0 itself. It's fine. It's really fine. Anyway, it doesn't matter. It's below the world, which is what I really wanted. And so what we're going to do next is just take a look at what this script is. So if you click on Overtime Manager and you scroll to the bottom, it has the Overtime Entity script attached. And what this does is it handles all the complicated stuff about making motion happen over time. This includes rotation and scaling. And so we're going to go create a brand new script, and we're going to call this Easy Moving Platform. And underscore entity. There we go. And you might wonder why we didn't start with this. Well, I really thought showing you on update and some of the ways that you kind of have to do motion would be helpful to understand like that is what's happening behind the scenes for this next script. Okay, open an external editor. All right, just like before, we're going to delete this first line. Click Enter, backspace the HZ dots, backspace HZ dot, press Control period, and re-import explicitly component from Horizon Core. With our script just about set up, we want to move over time. To do overtime motion using this utility, you type OV for overtime, click Enter to import overtime, and you'll see that imports from the overtime function file. We can then hit dot move to dot start parentheses, and then we want to tell it what to move, which will be self. So this dot entity is what we want to move, and we want to move to this dot entity dot position dot get dot add parentheses new vec3 parentheses 0, 2, 0, and then one more comma here, and it says how long do you want it to take in milliseconds, and we want it to take 2 seconds, which is 2,000 milliseconds, and the underscore is optional, but it makes it a lot more readable. Shift-Alt-F to make that pretty, Control-S to save, and that's it. One line to move to a destination, very, very simple, and this does it over time, which you remember all we were able to do last time in one line was just move to instantly, so this does it over time. Let's go ahead and check it out. We're going to attach that script to this other object. So we're going to have to remove the script that's currently on it. And now we can attach the Easy Moving Platform script. Going to hit World Simulation on, and there it goes. Beautiful. Now it gets stopped. It's not bouncing yet, but that was really simple. So let's make it better. To make it better, we're going to create a loop. To make a loop, we're going to create a local method called loop. parentheses, curly braces. Now ideally you want to have a better name than loop, but for today's tutorial calling it loop makes sense because it is a loop. And to get this loop started, we're going to use async. Now async in Horizon is inside of components the component class. And so we type async from inside of a component class. We can then hit enter and then dot, and we're going to use set interval to create a loop, parentheses, parentheses, arrow function, curly braces, and then what do we want to call the local loop? So loop, and press enter to get this dot loop. Parentheses is what calls it. Adding a semicolon is for my mental sanity, I guess. Optional for you. And now that we have the loop happening, we need to tell it how frequently. So after the curly braces, we type comma, and we want this to happen every 2,000 milliseconds. There we go. And what you need to know about set interval is that it happens after 2 seconds, which means it's going to wait 2,000 milliseconds before it calls loop for the first time. But we want this motion to start on world start. So we're going to write loop right here in parentheses, and we're going to manually call it the first time. So we call it, and then 2,000 milliseconds later, it gets called again. Now in loop, we're going to use our motion.start, and we're just going to arrow this down. There we go. Backspace. Clean this up. Nice. Control save. And we just want to make sure that this is working. So let's go ahead and hit clear. And we're going to go, wait one more second. Clear, clear, world simulation on, and there it goes. Just like before. Although this time you can see it continues moving up because it's a loop. Nice. I didn't actually mean for that to happen. Once again, we get upward motion continuously. That's fantastic. And if that's what you're going for, that's a lot easier to do than what we did previously. Or it's maybe similar difficulty, depending on your skill level with connecting and events with onUpdate. But yeah, I felt like that was a lot easier. Now what we want to do is get this bouncing back and forth. To do that, we're going to need a lot of the same things from before, right? So we need a start position, which is going to be starting at vector 3.0. Then we need a destination position, which will equal another vector 3.0. And I do recommend retyping all this because it is going to give you some good muscle memory. And we're going to stop there with creating those and then go move on to our is moving up Boolean. So we're going to say is moving up, which will equal true because it starts by moving up. And then in the loop, when we're done running all the code in the loop, we say is moving up equals not is moving up, which you'll remember flips the Boolean from true to false and vice versa. All right, so now we got is moving up set, and this loop now needs to use this is moving up. And to do that, we can actually use something very similar to what we created a little bit ago. But first, let's define the start position and the destination position. So on start, you'll remember that we did start position equals this dot entity dot position dot get, so just like before. And then we need to set the destination position, so we say destination position equals, and we take the start position and dot add start position dot add, there we are, and then parentheses. And what we want to add is that new vector from down here, so I'm just going to copy paste that to save myself a little bit of typing. Control C, Control V. Just for what it's worth, and when I started out, I did a lot of retyping stuff, so if you're inclined, feel free to retype that just to get the muscle memory. And now that we have our destination position, right here is where we can replace this with destination position. Now this will no longer continue going up forever, it'll actually just go straight to the destination position, which is perfect. Except we now have this Boolean to tell us if we want to go up. And you remember that we were able to do that, I think it's called the ternary operator. I should ask. I should ask to make sure that's what it's called. Let's, there are simple things. Ternary operator. Ternary operator. It's totally what it is, but I don't know how to pronounce it. Ternary. Does anyone have a pronunciation? Pronunciation. There we go. No, I was hoping somebody would spell it out for me. Ternary. I think I got it. If I'm wrong, somebody correct me in the comments. Okay, so anyway, we're going to use the ternary operator here, which, if you don't remember, was where we typed the Boolean value, then we typed the question mark, Then we said if it is moving up, we use the destination position, colon for or, we use the start position. So if we're moving up, we go to the destination position, else we move to the start position. And now we've got a simple one line of code for our loop. And that does the same thing that our super long script from before does. This is fantastic. Oh my goodness. I'm actually a little shocked right now. This is so much more improved than the one I wrote earlier. I'm very happy. World simulation on, and there it goes. And it should come right back down. Very fantastic. Let's just, there it is. There it is. So good. Okay, so how can we make this better? Well, this is where properties on the properties panel comes into play. Right here, we can create properties. And the first property we want to create is going to be the move, like the travel distance time. There's actually a couple things I want to cover. Give me a second to compile my thoughts and I'll be right back. All right, thank you. Okay, so the two parameters we want to do are the distance in meters. And parameters is another one of those things where you just got to memorize it and get used to typing it. So we type type colon prop types has a drop-down list for the types that it can be. In this case, it is a number. And then we can set a default. So we comma default colon, and the default here was 2. So we moved up by 2 meters. And then we can utilize that where we were typing in 2 by typing props is how you access the properties panel, and then dot distance in meters. And then the other one that we wanted to know was the loop speed milliseconds, which is the same thing as above. So I'm actually going to Control-C, Control-V, Control-C, Control-V, and change this to be 2000. So 2000. And then we can delete that line and Shift-Alt-F to make it pretty, Control-Save. And what this means now is if we take this guy here, Control-D, slide it over, we can now go to the Properties panel and change the distance to 4 meters, but keep the time maybe slightly different. Let's go to 1500. So it's really fast, 1.5 seconds, but it also means it'll get out of sync, which creates its own unique game mechanic where players have to time it just right. So it goes up, and it comes down, and now it's supposed to be slightly out of sync. That seemed right in sync. 1500 didn't save, or it did save. This one's 2000. Huh. Let's try that one more time. Maybe I want to make it twice as fast. Let's go to 750, like way faster. All right, wait and start. There we go. So now it's going. Oh, what? Am I crazy? Somewhere else. Oh. We forgot to swap this 2000 with the props dot loop speed milliseconds. My bad. And then we also need to swap that right here because we're using it in 2 places, which is kind of a magic number. You don't want to do that. There we go. We fixed that magic number by replacing it with a property or a variable. With that created, it's going to log on the console. I am going to change this back to 1500 because I think that's the appropriate amount of time, 1500. So now it's going to be extra fast, and you got to time it just right. Let's go ahead and hit World Simulation on. Oh, I got to unselect it. Woo! Let's try that again. There we go. And so you can see that one moves way faster, comes right back down, and you got to just time it just right to jump onto it. Fairly cool. Okay, there's one last thing I want to show you. Now this is going to require just a small little bit of camera explanation. You missed my sass. So anyway, an object like our shape that's going up and down has an upward direction, a forward direction, and those values we can get. And so if we rotate our upward direction to be facing that way, that would be the forward direction, right? You can also rotate the object's forward direction. So what I'm trying to say is the world has its own up, the world has its own forward, and each object has its own up and its own forward based on its relative location. What that means is we can utilize that relative forward direction to make it move in interesting ways. Let's try it out. So in the code, we were using startPosition.add with this vector value. If we just delete all of this code, and instead of adding to it with a new vector, we say this dot entity dot forward dot get. You can also do the same with the upward direction, but in this case we want to use the forward. And if we take that forward direction and dot multiply it we can multiply it by the property that we created for distance meters. And if we hit Control Save, that's going to give us a position based on the forward direction. If we go back into here and click on this, the forward direction is the Z value, which is the blue, so RGB XYZ, so B, blue, is the forward. We can rotate this by 90 degrees to move this one so that if we select the motion tools again, the blue is now facing this way, blue is facing this way. We might want to move these out this way like that, and then hit World Simulation On. And now we have mini platforms doing all sorts of things. And I mean, you can do so much with that, right? Because now it's different. So like, what if we took this, rotated it at a, let's go with a 30-degree angle on the red axis, and then hit World Simulation On, and it's going up like that. I mean, as you can see, this is a lot of fun. I encourage you to play with this. There's a lot more we're going to get to talk about, but I hope this helps you get started on making things move. If you have any other questions, feel free to leave it in the comments. This does have rotation and scaling options as well. So you might have seen that over time dot has rotate to and scale to. Try playing with that. Honestly, like, try doing that outside of this lesson and see what you can do. You can get an entity's start scale. You can get an entity's start rotation. Rotation's a lot harder. But yeah, feel free to play with it. I mean, if you click on an object, you can see the rotation value is listed here. So you could manually create a new rotation. But we'll keep rotation for another day, because that one, you start getting into fourth dimensional math. I love quaternions, but you're not ready. Just kidding. Anyway, we'll get into that. I can't wait. So without further ado, I will see you in the next one. Bye!